Okay, problem 1, convert 54 square feet to square yards. Okay, so we have a conversion problem, the same kind of conversion problems we've had. I know that 1 yard is equal to 3 feet, so I have a direct route from the type of unit this is to the type of unit that is, but we don't have a square feet and square yards conversion factor. So if I look at 54 square feet as 54 feet. Notice it's 154, it's 2 feet. Alright, so make sure that 54 doesn't happen more than once. Just 54 all by itself, and then square feet is feet. That goes over 1. And then I'm going to use this conversion factor here to convert to yards. I want this unit of foot to go away, so I'm going to multiply by 3 feet on the bottom, 1 yard on top. The effect of that is this unit of foot and that unit of foot are the same, but opposite sides of a fraction, they cancel. I have a second unit of foot on top. I want to get rid of it. I want to change to yards, so I do a second multiplier, 1 yard over 3 feet. It's always 1 yard over 3 feet because that's just where feet have to go. This unit on top, this unit on the bottom cancel. What I'm left with is 54 on top, 3 and 3 on the bottom. And what I need to do at this point, I can do this, I'm sure all of you can do it also, 54 divided by 9 equals 6, but let's just say the number's a little uglier. Any top number divided by any bottom number. So that's what you'd actually type in a calculator on this problem. If numbers happen on the top, you'd multiply. So let's say the 3 is on top, 54 times 3 times 3. Since they're on the bottom, 54 divided by 3 divided by 3. That's how you type in your calculator. Otherwise, your calculator, not being smart, not knowing how to think for itself, won't understand, hey, we're supposed to divide by both of those 3's. So if I type in 54 divided by 3 divided by 3 equals 6. If I type in 54 divided by 3 times 3, because that's what I'm looking at, 3 times 3 on the bottom, my calculator thinks that second 3 is on top, all of a sudden it says the answer is 54. So be careful, that's how you type it in your calculator correctly. Yards is yards squared, so we have the correct unit with the correct number of square yards. Number 2, find the number is the directions, and they give us a sentence there that gives us an equation. So find the number, always establish what the number is, x equals the number. And then you start reading the equation in order to write it properly. So sum of, there's the word and, so we're adding together twice a number and 29. So the number is x, so twice the number is going to be 2x. That's being added to 29. No parentheses are necessary there because I'm not multiplying by the sum. The product is 2 times a number, 2 times one thing. It's being added to 29. The word is always gives me an equal sign, and 49 and 47 is just the number 47. So straightforward, pretty simple equation to write there. Once you've written the equation properly, job 2 is to solve the equation. 2x plus 29 equals 47. I'm going to move the 29 over to the other side. Anytime we move across the equal sign, the sign changes, so positive 29 becomes negative 29. 2x is left on the left-hand side. And 47 minus 29, I'm going to subtract because the signs are different, and 47 is bigger, so it's positive. We divide both sides by 2, that gets me x equals 9. If we test it out, 2 times 9 is 18, plus 29 equals 47. That's true, so that's the right answer. Number 3, find a number. Then the magic words such that, which means an equation is about to happen. Okay, 6 less than twice the number is 12. So, first thing I'm going to do again is establish the number. X equals the number. So anytime they say the number or a number, they're referring to the letter X. So, less than means subtract in reverse order, so we do the second thing minus the first thing. So, twice the number, 2 times x, minus 6. So again, 6 and 2x are being subtracted, but again, less than subtract in reverse order. This goes second, this goes first. The word is equals, and 12 is the number 12. So once again, you write an equation based on the words, then you solve the equation you're looking at. Negative 6 moves across to become positive 6. 2x is left on the left-hand side. 12 and 6 are both positive. They add together to make 18. We divide by 2, we get x equals 9. That's just a coincidence they came out the same answer. That's not necessarily going to happen on your test. Number 4. What decimal part of 38 is 3.42? What decimal part, D, of 38 times 38 equals 3.42? A decimal or a percent or a fraction of means to multiply. So D times 38 equals 3.42. The easiest way to solve this would just be immediately divide by 38. And then get your calculator out and type in your calculator. 3.42 divided by 38 equals, comes out to 0.09. In your homework, some of you have been trying to get rid of the decimals on these, which is fine. You can do that if you want. Let's say we did want to do that. 38D is equal to 3.42 is our actual problem. If I'm going to get rid of decimals, I'm going to write this prettier. So 38D is prettier than D times 38. This has 2 decimals. This has 0 decimals. What some of you have been doing wrong is you've been counting 38D as separate pieces. So you make this 3800 and you make this 100D. That's not good. This is all one term, so it gets fixed all by itself, 3800D. And this is all one term, 342. We divide both sides by 3800. And then, of course, reduce as much as possible. You can get 9 over 100. I'm personally fine with that. Using a calculator to do complicated division, since you've already mastered division, is fine with me. I would recommend that first technique. Both these answers are right, though. Number 5, simplify -4 to the -2nd power. The thing to remember about powers is this power is attached to this entire thing because the parentheses are there. So what's being raised to the -2nd power is -4. It moves where it belongs to the bottom because currently it's on the top. Once you move it where it belongs, the power becomes positive. The base stays negative. What's in the parentheses stays whatever it is. The power changes to the right sign. And once I moved -4 to -2 off the top into the bottom, that leaves me with a 1 in the top. This one's not that one. There's a 1 up here that's being multiplied by that. There's still a 1 down here being multiplied by that. That doesn't be written. Once I get to this point, I evaluate -4 squared in parentheses. That's minus times minus 4 times 4, which makes positive 16. So positive 1/16 is the answer. If it looked like this, -4 to the -2nd power, now only the 4 is being raised to the 2nd power, the minus sign isn't, it stays on top. -1 over 16 will be the final answer for that. So again, the presence of parentheses does make it, it's important the parentheses are there, it makes it a different answer than if the parentheses weren't there. So be cautious when powers are involved. If parentheses are involved also, you need to deal with that properly. Number 6, fraction of something is something. So 3 1/5, what I would do is I'd write that as 16/5. I don't like to deal with mixed numbers in algebra, so as soon as I see a mixed number, I'm going to change it to improper fraction form. 3 1/5 is exactly the same as 16/5. This is the better form. Of what number? That's times x is 208. So job 1, get the equation written properly. 16 over 5x equals 208. This is a fractional coefficient, and the fix for this, in order to solve this, I'm going to put that over 1. Make everything into a fraction. I'm going to multiply by the reciprocal. 5 over 16 times 16 over 5, the 5 and the 16 cancel, leave me with 1x, which is what I'm always looking for in an equation. If I want to multiply the left-hand side of the equation by 5/16, I'm required to multiply the right-hand side of the equation times 5/16. 16 divided by 16 is 1, 5 divided by 5 is 1, so I get 1x. 208 divided by 16 is, let's see, that's 3. And that reduces to 1, so 13 times 5 is 65. Number 7, easiest problem on the test probably. I haven't looked at the whole test yet, but that's the easiest problem in my opinion. G of x equals that, find g of -5. This means go to function g, which is this expression, change x to -5. So -3x minus 5, put -5 there, then work it out correctly. Some of you on the last test had a problem similar to this. A lot of carelessness happened here, or just general errors. Multiplication, subtraction. This happens first, that happens second. Multiplication rule, you multiply the numbers, same sign gets you a positive, -5, 15 minus 5 makes 10. So make sure you follow the order of operations correctly, make sure the signs involving integers happen correctly. Same sign in your multiplication create a positive, opposite signs in an addition subtraction create subtraction. The bigger number determines the answer for an addition or subtraction problem. Number 8, 3 4/5 k plus 2/5 equals 7/10. Once again, we got a mixed number. I don't like mixed numbers in algebra, so I would change this to 19/5. The k is officially in the numerator. I'd recommend putting it up there just instead of putting it out in front. Just slide it up to the top there so it looks like that. Plus 2/5 equals 7/10. Okay, here's a fraction equation. I'd rather not do a fraction equation, so I find the least common denominator of this whole thing is 10. And I'm going to multiply 10 times each piece. Each piece is what's being added and subtracted or equal to. So this piece plus this piece plus that piece. So pluses and equals and minuses separate pieces that are going to be multiplied by 10. When you multiply, do it in 2 steps. Divide first by the bottom, then multiply the result times the top. 10 divided by 5 is 2, times 19k is 38k. 10 divided by 5 is 2, times 2 is plus 4. 10 divided by 10 is 1, times 7 is 7. So that's job 1. Get rid of the fractions after you've created this improper fraction structure. Get rid of all the fractions. And then you're left with an answer, an equation that has the exact same answer as the original equation. It's easier to do. I would move the 4 over to the right, so -4 goes over here. Anytime you move across equal sign, you change the sign. Integer addition or subtraction, depending on sign. These are opposite signs, so I subtract. 7 is bigger, so it's positive. 38k is left on the left-hand side. And finally, divide both sides by 38. In fact, it came out, number 8, came out to a fraction on your study guide. Chances are it comes out to a fraction on your test also. Don't be worried about that. Just make sure you carry through the steps properly. Number 9, solving an equation. Job 1 of this one is to simplify as much as possible. Here's my equal sign. There's the separation between the 2 sides of the equation. The left-hand side of the equation, I've got some like terms. The right-hand side of the equation, I have a distributive property to deal with. So a couple different kinds of simplification going on here. So 5p is behaving itself. It gets to stay 5p. -2 minus 15 makes -17. The signs are the same, so I added. 15 is bigger, so it's negative. Put the equal sign right where it belongs. On this right-hand side, -3 times p is -3p. -3 times -5 makes +15. When you multiply, the signs do matter. So these signs are opposite, give me a negative. These signs are the same, giving me a positive. Once I simplify both sides, I have a letter on both sides and a number on both sides. It's just a matter of me deciding which side I want to send things to. I'm going to take my 3p over here, becomes positive. Stick it under the positive 5p. I'll take the -17 off this side, move it over, become positive 17. If I put my hand up in between the 2 sides, one side should have all the letters, one side should have all the numbers. It doesn't matter which side you choose to go to, just make sure that separation's there. Then add or subtract based on signs. These signs are the same. I add, put a p on that, because they both have a p, I can add them together. These have the same sign, I add. They're both positive, so it's positive. 8p equals 32, divide both sides by 8. That gets me p equals 4. That one comes out to a whole number. Chances are it comes out to a whole number on the test. So just be cautious that you carry through the simplification steps properly, changing the signs when you move things over, adding and subtracting correctly based on signs that are there. Number 10, simplification once again. Looking at the separation, there's my equal sign. The right-hand side, 6, you can't get any simpler than that, so that's fine. The left-hand side has 2 parentheses happening, so I've got this one and this one. So if I deal with the first one, I got a minus sign outside the parentheses. That minus is distributing through the parentheses. minus times x makes minus x, minus times minus 5 makes plus 5. You might even want to put a 1 there, minus 1x. And on the green one, this 3 is distributing through that parentheses, but this minus sign is attached to it. So be careful. Minus 3 times x makes minus 3x. Minus 3 and minus 2 make positive 6. I'm making terms, pluses and minuses. So if I get a negative product, that makes a subtraction. If I get a positive product, that makes an addition. It doesn't change things into multiplication. So minus x plus 5 minus 3x plus 6 is what we get out of this side, equals 6. And what's left to do on the left-hand side is like terms. These are both on the left-hand side, so it's just a matter of adding these two things up because they're on the same side by the sign rule. So signs are the same, I add. The sign of bigger number 3 is negative. Same thing here. These two things are like terms. They're on the same side, so I just add them together based on sign. 5 and 6 are both positive, so you add. 6 is bigger, so it's positive. So negative 4x plus 11 equals 6. At this point, that's the only x term. All the numbers should go to the other side, so minus 11 goes over here. Negative 4x left on the left-hand side equals negative 5 left on the right-hand side. And divide both sides by negative 4. I can't divide 5 by 4 evenly, but I can make it into a positive since they're both negative. 5/4 would be the best answer for this one. That one came out as a fraction, so it probably comes out as a fraction on the test. Number 11, simplify by adding like terms. Okay, notice this one has negative powers in it. We don't like negative powers. So the first thing I would do is I'd fix it so they all have positive powers. So this right here is 2x over y squared. This one here is plus 3x over y squared. This one here is minus 2x over y squared. And this one here is going to be plus 4x over y squared. We're looking for same letters, same powers, same locations in order to be like terms. X to the first on top, 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 top. Y squared on bottom, 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 bottom. They're all 4 like terms. So to get the answer, I simply have to add and subtract the coefficients of these things and stick an x over y squared on it. What made them the same is x over y squared. That's what makes them the same. All I need is a new number in the front. So 2 plus 3 is 5, minus 2 is 3, plus 4 is 7. So 7x over y squared. No negative powers in final answers, so make sure you go that far. If you left negative 2 power, if you left your answer 7xy to the negative second, you're going to lose half credit because I've already told you enough times that negative powers will not be accepted for a final answer in this class. So always positive powers. Number 12. Expand using the distributive property. Once again, I got some negative and 0 powers happening here. So the first thing I would do is fix each of these guys individually. I want the 0 powers to go away. I want the negative powers to move where they belong. So here's my original structure. I got a parentheses there. 5 is right where it belongs. It's to the first power. It's currently, there's no fraction there, so it's currently in the numerator. X to the third power belongs in the denominator. Y to the 0 is gone. You can strike out 0 powers as long as they're being multiplied by other stuff, which this is, so y to the 0 is irrelevant in that one. Then I've got x cubed right where it belongs in the numerator. Y to the 0 can be struck out. I'm going to put it over 1 just to make sure we establish top and bottom of a fraction there. And then I got minus 2. Y cubed is right where it belongs. X to the 5th belongs at the bottom. Be careful. This negative 2, a lot of people see minus sign, they immediately start moving things around. First power, powers are what establish you should move up and down in a fraction. So negative power on x moved it to the bottom. Positive first power on 2 leaves it in the numerator. Even though it's a negative 2, it's a first power, so it's right where it belongs. So that's job 1, is to fix everything. Then you distribute. So I'm going to move 5 over x cubed times x cubed over 1. I'm going to do 5 over x cubed times negative 2y cubed over x to the 5th. Once again, when I distribute, I'm going to create a product here and a product there that's going to be either added or subtracted based on sign. So top times top, when I multiply fractions, that's how you multiply. Top times top is 5x cubed. Bottom times bottom is x cubed. I know it reduces, we'll worry about that in a minute. 5 times negative 2 makes negative 10. So notice it becomes subtraction because of a negative product. Negative goes with subtraction. Y cubed on the top. And then x cubed x to the 5th makes x to the 8th on the bottom. So if you do happen to have the same letter happening, you add those powers by the power rule. The black term is exactly how it should be. Y is to the 3rd, x is to the 8th. There's one of each letter. Powers are positive. All's great about that. The red term, though, we don't want to have multiple x's in the final answer, so there's too many x's. This is exactly the same as that, so they cancel out. If everything cancels, you're left with 1. In this case, there's a 5 left over, so 5 minus 10y cubed over x to the 8th. Notice this fraction ends here. Okay, so we don't extend this fraction, we're all the way across like that. I've seen people trying to do that a little bit. Term 1, term 2. Term 2 is a fraction, term 1 isn't, so make sure that it keeps separated. Non-fraction minus fraction in this case. Number 13. This will be the exact expression that you're going to have to evaluate. All I'm going to do is change these two numbers. And the very first thing I would do on this problem is that. A to the 0 is equal to 1 no matter what A equals. And if you do that immediately, you don't have to worry about, oh, should it be negative or positive? Because it doesn't matter, because A to the 0 equals 1 immediately. So that's the first thing I would do. I wouldn't even use this expression at all. I would rewrite it as that expression. The other thing I would do before I start throwing stuff in here is I'd figure out what this thing equals. So I know A is equal to negative 5, so I know that A cubed should equal negative 5 cubed. That's sign and number cubed. 5 times 5 times 5 is 125. And a total of 3 negatives makes it negative 125. So if I come back over here then, I know B is equal to 2. And I know 1 is equal to 1. And my original structure is this right here. A cubed goes in front, that's negative 125. 1 is 1. And minus B makes minus 2. And just real quick, that minus sign is just right there. B is equal to 2. So again, minus is part of the original structure. I'm substituting a 2 for B because that's what B equals. That leaves me with negative 125 times negative 1. Since these are like terms, I can add them together. The signs are different, so I subtract. 2 is bigger, so it's negative. And multiplying these two things, negative 125 times negative 1 makes positive 125. When you multiply two negatives, make a positive. Number 14, simplify. We've got a bunch of stuff on top over a bunch of stuff on the bottom. I'd separate the two pieces and then put answer over answer. So negative 3 bracket 4 parentheses negative 3 minus 1 minus parentheses 6 minus 2 and bracket, that's the top. And then we got the bottom, which is 5 parentheses negative 3 minus 1. So looking at the top, obviously much more complicated than the bottom. We'll get to that in a minute. As far as the order of operations are concerned, I would start off with these two parentheses. I'd follow that up by doing this product, and I'd follow that up by doing this subtraction, and I'd follow that up by doing the multiplication. That's the order of things that I would do in this case. So I do negative 3 first, bracket 4 parentheses minus parentheses. Within the parentheses, these signs are the same, so I add, bigger number is negative. These signs are different, so I subtract, bigger number is positive. So negative 4 for that, positive 4 for that. Next thing I would do would be negative 3 bracket, and I do this multiplication. 4 times negative 4 is negative 16, and then of course I've got minus 4. You can make it look a little prettier. Minus parentheses 4 is the same as minus without parentheses 4. Then I would do, I got negative 3 bracket. I would do my negative 16 minus 4. Those signs are the same, so I add. 16 is bigger, so it's negative. And finally, I would multiply my last step. These two numbers are both negative, so I get a positive 60. So the top comes out to positive 60. The bottom, all I have to do is evaluate this first. That gives me 5 parentheses negative 4. Signs are the same, so I added. 3 is bigger, so it's negative. Then I multiply 5 times 4 is 20. Opposite signs gets me a negative. Once I get a top answer and a bottom answer, the result, 60 over negative 20, is then evaluated through division. The signs are different, so I get a negative. 60 divided by 20 is 3. That'd be the most efficient way to do that. And number 15, a base of a right prism 7 inches high is shown. Find the surface area of the right prism. So let's focus on the directions. Find the surface area. So the first thing I'm going to do immediately is write down my surface area formula, which is 2b plus ph. My intention is to figure out what b, p, and h equals. So b is equal to something, p is equal to something, h is equal to something. Once I get all the information I need in this box, then I'm ready to evaluate. Okay? B and P come from this figure here. And H, if I'm trying to find surface area, H is a three-dimensional height. I'm looking for a three-dimensional picture. I don't see a three-dimensional picture, which tells me that the height is going to be within the words. So if I see a three-dimensional picture, I might be able to see the height on the picture. If I see only a two-dimensional picture, I'm going to expect to see the height up in the words. So 7 is H. Okay? As far as B and P are concerned, B is the area of this, I guess, joined rectangle picture. So I want to find the area of this thing. What I need to do is I need to split it into two rectangles. So if I split there, for example, this is 5, so this must be 10, because that's 15. Those two pieces have to make that. This rectangle here has a length of 10 and a width of 4. So the area of that piece there, we'll call this piece 1, is 40. And then if we look at this piece here, it's got a length of 12 and a width of 5, so that, and we'll call this piece 2. Area of piece 2 is going to be 12 times 5, which is 60. So if I add the two areas, 60 and 40, that gets me a total area of 100 for the area of the base. As far as perimeter of base is concerned, we want to add up all the sides. And again, I have this missing side we've already established as 10. That's 8, that's 4, that's 10, that's 5, that's 12, that's 15. All 6 sides are known. So 5 and 8 and 10 and 4 and 15 and 12 are all the sides. If we add them up starting here, 12 plus 5 is 17, plus 8 is 25, plus 10 is 35, plus 4 is 39, plus 15 is 54. Just like that, I've established the values of B, P, and H. And this right here tells me exactly what I need to do to B, P, and H in order to find the surface area. So I'm supposed to do 2 times B plus P times H. Okay, so if I write that out exactly as it's written, surface area equals 2 times B, so 2 times 100, plus P, which is 54, times H, which is 7. Alright, so I just take this expression, replace these 3 numbers with the variable values we just found, and then the order of operation kicks in. Product, product, sum. Surface area equals. Order of operation says products happen first. 2 times 100 is 200. 54 times 7 is 378. And then addition happens after all the multiplication. So multiply to get an answer, multiply to get an answer. Add to get the surface area. So 578 is what the sum of those two numbers is. The unit of length is inches in this, and the area is always in inches to the second power, or whatever unit you're dealing with to the second power. So 578 inches squared will be the final surface area for that problem.